we're going to continue our discussion in section 1.2 with some more vocab words. So we just looked at the idea of population and sample. Here we're going to look at variables. Okay. So variables are going to be characteristics of individuals from the data set. Variables in statistics are different than variables in algebra. Right? In algebra, if we say the word variable, we mean an x or a y or something like that. Right? It's an unknown value. Where when we're thinking about statistics, variables record characteristics of peoples or things. So as we're kind of thinking about this definition, we want to separate it from things that we've seen before, and we want to think about this as being characteristics, right? Not just letters that are being used to represent numbers. Right? When we're dealing with statistics, we're going to have two main types of variables. Our first type is going to be categorical variables. Categorical variables are sometimes referred to as qualitative variables because they describe qualities of the object of interest. Right? So they're qualitative because they describe qualities. Qualities meaning words, right? The values will be categories. Things such as hair color, gender, eye color, letter grade, things along those lines, right? So eye color could be brown, could be blue, could be hazel, right? Could be green. Those are words, not numbers. So categorical, we're thinking about categories that we can fit these different characteristics in that we're looking at. Right? Numerical are other types of variables. And numerical are quantitative variables. They describe quantities, right? Quantities meaning numbers of our objects of interest, right? Things such as height, weight, test scores, something along those lines. We're going to make a little note here that when we're thinking numerical variables, we are thinking characteristics or qualities that are usually either measured, such as weight or height, counted, or calculated. Right? All of these being number-based variables. Right, in the next couple of examples, we're going to go through and we're going to talk about these different types of variables. Okay, so we're going to start with example 2. The data in this table here that we're looking at are an excerpt from a crash test dummy studies in which cars are crashed into a wall at 35 miles per hour. Each row of the data set represents the observed characteristics of a single car. The head injury variable reflects the risk of the passengers' heads. The higher the number, the greater the risk. So for each variable, state whether it is numerical or categorical. Before we go any further, just to kind of throw something out there that we saw in the first section, right? This paragraph that's giving this all of this information, right? This is our context for the problem, right? Context is key. If we don't have this context, then we don't know exactly what's going on, especially with our head injury numbers. We don't know what those numbers mean. Right? So when we're dealing with statistics, we definitely want to be paying attention to not just the numbers, but the entire problem and the context that's being given to us. Right? So categorical variables. Right? So looking at this, we have make, model, doors, weight, and head injury. So our categorical variables, definitely make and model. Right? Those are pretty easy to pick out because they're words. Right? So there are categories that these fit into. Right? What is the make of our car? What is the model of our car? Doors and weight are pretty easy numerical values that we can pick out here. Again, numerical values are either measured, counted, or calculated. Now, as far as this example goes, our head injury category, we're given some context, but we're not given a bunch of information. Right? So we're just going to say as far as our head injury category, we are unsure, right, without more detail. So in order to kind of determine whether this is something that's going to be categorical or numerical, we might want to do a little bit of further investigation before we get there. All right, let's look at one more example, kind of exploring these ideas of categorical versus numerical. So suppose you were interested in the crime rate and rank of each of the 50 United States. You obtain the information from the following table. Identify the population, the sample, our variables, and our type. We're asked what do we call the numbers in the table, and what are some questions of interest. All right, so population. Going back to our definition in the previous video, kind of where we started in section 1.2, remember population is all. So if we're looking at this information, we are probably thinking about all 50 states. Okay? So population is going to be all. Right, our sample. Well, our sample are going to be the states that we have in our table here. Okay? So we have 4 states here, Alabama, Alaska, California, and Idaho. Right? So our sample is a smaller subset of this group. Right, our variables and type. Right, well, our crime rate. Our crime rate is definitely a numerical, I lost a C there, numerical variable. Right? We know it's a numerical variable because it is a number. Now, even though rank is a number, rank is going to end up being a categorical variable. So rank is kind of one of those weird things. Rank turns out to be a categorical variable because if we think about what we said about numerical variables in the previous bottom of the previous page, we said they're usually measured, counted, or calculated. Right? As far as rank goes, right? Rank is not measured or counted. Because it depends on other data values. Right? It can change. Right, so one way to kind of think about this, if we were thinking weight, for instance, right, you step on a scale, you are going to get a weight. That weight is not going to be changing. Right? So that's definitely a numerical variable. However, if you were to compare the weight of 10 people, depending on the group of 10 people that you pick, right, your ranking in that group of 10 people could be different. So this variability and this ability to change means that rank is one of those weird numbers that's not actually a numerical variable. It's actually a categorical variable. So as you're going through the homework in the section, just kind of be aware, pay attention to that. Anytime you see rank, whether it's talking about crime rates, class rank, anything along those lines, just remember, because it depends on other things and it can definitely change really easily depending on our data set, that is going to be a categorical variable, not a numerical variable. All right, a couple last questions here. What do we call the numbers in the table? Well, the numbers in the table themselves are data. Right? Again, so we're working with this data. Remember that, right, we like context. So as we're going through and thinking about problems, right, we would definitely want to think about the context of our data. What are some questions of interest? There's a lot of different things that we could write down here. So I'm not necessarily going to list all of them, but different things that we could think about as far as questions of interest What would we have as far as ordered rank goes? What kind of other data, right, was obtained in the survey? We could say, you know, compare the highest and lowest right. Really, we could do a bunch of different things with this type of data set. Right? So as we're going through and we're thinking about section 1.2, right, the big thing that we want to keep in mind is the difference between our categorical and our numerical variables. Right? Numerical variables are numbers. Right? These numbers are not going to change. Our categorical variables are descriptions about something. Right? And depending on the scenario, depending on the different type of data that we're looking at, there is a possibility for variation as we're going through and we're looking at these different things.